Welcome back. Today we will talk about motion under gravity. So, let's assume that a particle is thrown from this position upwards. What happens in general? Our experience says that if I throw a particle upwards, it comes back. So why does it come back? Why doesn't it go like that, up and up and up? Because there is something called as gravity which pulls the body down. So any particle thrown up with an initial velocity will rise up to certain extent and goes to a final point where the velocity becomes zero, and then it returns back. So if velocity is decreasing, means the acceleration is opposite to that. So the acceleration is this way, and scientists have found, and you will also find it, that the acceleration of any particle which is thrown upwards or downwards is always, the acceleration is downwards, which is 9.8 meter per second squared. This is the value of the acceleration. So when a particle is thrown up, it goes to a certain point and returns back. So we are talking about one-dimensional motion. So therefore, that single dimension, these are the equations of motion which we have learned in the last session, last class. So today we will learn about motion under gravity. That is, if a particle is thrown vertically upwards, it goes up to a certain point, then comes back. So we are trying to see the relation among these physical quantities. The displacement is height h from here to here. So if I know initial velocity, I know acceleration value, then can I find h is the question. Yes, these two are more than enough to find h. How? Because we know final velocity is 0. That means if these two are given and you know that what height it raises because of because of the final velocity becoming 0, that height h can be calculated by Vi, A and V final. So using this equation, I can find that. Now, let me write this equation. So S as h is equal to V final square, which is 0 square, minus V initial square. V initial is upwards. So if I take upwards as positive, then it will become plus Vi whole square over 2 times acceleration. But acceleration is downwards. Since I considered upward as positive, I have to consider downward direction as negative. So minus, we will call this acceleration is g, is equal to 9.8 meter per second square. This is the general way of representing gravity. So minus g. So this h becomes equal to this minus and this minus become plus, and 0 goes. Vi squared over 2g. So this is the equation for the height to which the particle rises when it's thrown upwards. So we have found the height. Now, can we find the time taken to rise up to this point? Yes, because I have Vi, I have A, I have Vf, I can use this equation to find t. So if I rearrange the terms here, this t can be brought here, A can be brought here. So using that, I can find the value of time taken from this equation. T equals V final minus V initial over A, which is equal to 0 minus of plus Vi, because upwards is positive, then downwards is negative, over minus g, which gives me time t is equal to Vi over g. This is the time equation. So, if I am given initial velocity, if I know acceleration, I can calculate the time taken to rise up to the maximum height h, and also I can find the h value. So this is time taken to raise, this is the height to which it raises. So we have understood about motion of gravity, which is a one-dimensional motion. Alright, we will talk about it later on.